Hello and welcome to the TID Water and Power Podcast. I'm your host, Constance Anderson, and on this month's episode, we're discussing the district's combustion turbine generation fleet. California has set a goal of 100% carbon-free retail energy by 2045, and as such, natural gas power plants have come under fire. With extreme heat waves like we've experienced across the state the last few summers, and will likely experience again this summer, the need for reliability and available generation capacity remains. On this episode, I'm joined by TID Combustion Turbine Department Manager Mike Tehada to discuss the district's combustion turbine power plants and the role these power plants play to ensure reliable and cost-effective power for our customers. Mike, thanks for joining us.
All right, glad to be here.
All right. So let's start with your background. Can you tell me about your history before joining TID?
My normal work history really started, I did 11 years in the Navy. I was a power plant technician and then supervisor there. And once I got out, I came back to California and did 5 years at a power plant in Stanford, ran by GE. And then since then, I've been here at TID.
Okay. You've been with TID for about 17 years, is that right?
Right. Started in 2006.
Okay. And what was your progression like here at the district?
I was an operator for about 10 years, switched to supervisor. I did that for a couple years, and then I took over for George Davies about 4.5 years ago. This is my 5th year as department manager. Okay,
great. All right, so I'd like to start with kind of a higher level profile of TID's combustion turbine portfolio. How much of TID's maximum generation capacity is natural gas?
We're in the 60% range. We can do about 500 plus megawatts.
Okay, very good. And just for a little bit of context, in these hot summer days that we're seeing now, our peak load could be anywhere between 550 to 650 even, depending on.
I think these last 2 years we've seen approaching up above 700 even.
At our peak.
At our peak.
Yeah.
And so we definitely need as much power as we can get.
Absolutely. Absolutely. All right. So that's kind of speaking in like max capacity terms, but the actual amount that we generate from our natural gas plants is different year to year. Is that fair to say?
Correct. Yes. It depends on a lot of things. There could be a large hydro year here in the valley. There could be a large hydro year in the Northwest where we get a lot of our power from. And there's just many factors involved in this.
All right. So you mentioned a high hydrology year, which would be like what we experienced in 2017. How did that affect the role of how we ran our natural gas plants that year?
Well, if you're going to run more hydro, et cetera, then you're just going to run the power plants a little bit less, and they're going to be more. The more time might be during certain hours of the day or when there's really just a peak load, and then you don't necessarily, you may be able to turn down the larger plants and just use your peakers. So it depends on what all factors are coming in.
Yeah. And let's talk a little bit more about what some of those other factors might be. Can you tell us a little bit about some of the specifics that go into making those decisions?
It could be natural gas prices, which kind of leads you into EIM, because EIM works on, we tell them, hey, it costs us this much money to run our plant per hour or per megawatt, et cetera, a minute. And that's based on the cost of maintenance. And, we figure all that individually per plant because every plant is different. So they take that into account. So EIM might ask us to run. There could also be just what are our local needs. There could be weather situations. Is the sun's out, but there's a lot of cloud cover, so we have less solar. It's a combination of things, and it changes daily, and it's not always as predictable as you'd think it might be.
Sure, I would imagine, yeah. Even just, this year, the East Coast is experiencing the fires from Canada. We've been in that situation before where there have been fires to the north of us that have come over the area, completely blocked out solar generation. So we've had to, in those instances, rely a lot more heavily on our natural gas fleet.
Right. The fires of a couple of years ago put clouds at the end of summer. We weren't quite into fire season, but it was at the end of summer. And I remember that pushed our generation up quite a bit. It made the demand even higher than normal.
Right. Absolutely. And I think you touched on something there too, that just the seasonality of it, right? That we know our load's going to be higher during the summer, specifically certain months, lower in the winter time. So that's a consideration as well.
Right. And those shoulder months seem to change a lot lately. In the last 5 to 8 years, you could say the shoulder of, we would be done with peak loads usually, say, into the beginning of September. Last couple of years, we've seen higher temps in the end of September and even into October. So that affects when we can do maintenance, and what those loads are going to be late. It has a large effect on everything. Yeah,
kind of shifts the whole schedule. So I'd like to circle back to when you mentioned the EIM, or Energy Imbalance Market. We had done a previous podcast with Dan Severson back on episode 15 in July of 2022. But can you go into a little bit more about how our participation in the EIM has influenced how we operate our natural gas facilities?
It's caused us to run more some of the plants, and because they take a look at the cost of all plants that are in EIM, and they say to themselves, okay, well, plant A costs X, plant B costs Y. They make a decision on which one's the cheaper to run. So you're bidding in, hoping to get ran. And based on our prices, we often run. We may run more depending on the factors and what we've put in for our maintenance costs. And so we have to be careful about making sure we recoup those maintenance costs. And so we're constantly balancing that.
Yeah, because truly there's a trade-off there, right? With the energy that's being generated, there's a cost on the wear and tear and maintenance side of things.
Correct. If we make a mistake with the numbers we've provided them and say that we can run for a less price, it may cost us in the long run, because we're making money today because EIM's running us, paying us, etc. But then later, if I have added maintenance costs or more often maintenance costs, then I have to make sure those were done correctly, or in the long run, it will cost TID money, even though in the short run, we're making money.
So in factoring in the different ways that we have to run the plants based on our participation in EIM, what are there any learning opportunities that have come out of that with regard to how often they ask us to run our plants?
For sure. At the beginning of EIM, when we very first joined, we were starting and stopping WEC, or as we say, transitioning, where we'd go from a full, no plant online to the full plant or half plant. We did that quite often, and we were doing it sometimes as much as 2 and 3 times a week. In the past, before EIM, we averaged about 10 starts a year.
Oh, wow.
So we went from 10 starts a year to as much as 2 or 3 a week. And with this type of plant, we knew at the time, even when we tried it, that it was going to increase maintenance. It was going to increase or decrease reliability and give us issues. So we tried it at first. We scaled it back a little bit as we went. And then the last thing we've done is really pulled it all the way back to where we're minimizing everything down to about 20 starts a year. And that includes our outages, not just EIM, so that we can make sure we stay reliable and not do much damage to the equipment. It's going to be damaging because it's just the way this plant is built. But we're trying to balance between making sure we make money and make EIM valuable and keeping the plant reliable.
Makes sense. All right. So before we talk about the specifics of TID's combustion turbine fleet, can you give us a general explanation as to how combustion turbine power plants actually work? What's the process like there?
Well, the starting point is that there's a gas turbine engine. That gas turbine engine, if you wanted to compare it to your engine in your car, you would say that the difference is this gas turbine is a big pinwheel. It spins. You have a motor that starts it spinning initially. Once you get it up to a certain speed, you add some gas in there. There's, similar to spark plugs in a regular engine, there's igniters. That starts an explosion. That explosion continues by once the initial explosion happens, the explosion continues, which keeps air drawing into the pinwheel, and then it just keeps itself sustaining so that you can turn off that initial motor. And that spins, and it spins a generator, and you make power.
Okay. So similar to using water for hydropower, it's just the fuel that changes from generation to generation.
Correct. In the hydro, the water will keep the turbine spinning. You don't need an explosion. In the wind, the wind's turning that blade. It's got to be a high enough powered wind, which is why you don't see wind turbines everywhere. They're in more particular spots. You have to have something to keep it spinning. For us, that's natural gas.
Very good. All right. So are there different types of combustion turbine plants?
Yes. And so the main two differences would be simple cycle versus combined cycle. A few of our plants are simple cycle. 2 of our plants are combined cycle. And the biggest difference there is if you're simple cycle, it's a gas turbine, it turns a generator, it makes power, nothing else goes on. If you're in a combined cycle, you still have a turbine, you're still spinning to make power, but the difference is the exhaust fumes, similar to your tailpipe on your car, they go into a boiler, turn that water into steam. That steam drives another generator through a steam turbine, which creates more power. So you're not wasting that exhaust gas. So that makes the combined cycle a little bit more efficient. And that's the main difference.
Okay, very good. Okay, so now let's talk a little bit more about the specifics of TID's fleet. When was the first gas-fired power plant for the district built?
In around 1985, Walnut Power Plant came online, and it's got 2 small simple cycle engines, and they do about 24 and a half megawatts apiece for 50 megawatts.
How often do we use those? What does the runtime look like on those guys?
As low as 20 to 40 hours a year. So they're really just more of an emergency situation. And there's certain years that most of that 20 to 40 hours is just emissions testing. It's not even for us to try to make power. It's just a byproduct.
Okay. So that was our first natural gas plant. And then Almond Power Plant was the next to come online. Is that right?
Correct. And that was around 1995. So Almond has a capacity of 49.9, and the reason for the strange number there is at the time the CEC would stop us if you were a 50 megawatt and above plant, more regulations. So every plant built in that era, you'll see other ones, Modesto, et cetera. Oh, we can only do 49.9. That's our maximum, because you don't want to be tagged with those extra issues from the CEC.
Oh, that's a smart move.
That plant in particular is a combined cycle, has a boiler. Difference being between that plant and WEC, it does not have a steam turbine. So it's still combined cycle, uses a HRSG, which is a heat recovery steam generator. And then that steam is just used for other processes. So it's not wasted, but it's not driving a steam turbine. So it's still not quite as efficient as WEC. Interesting.
Okay. Oh, what are some of those other processes that the steam generator might be used for?
There's a chiller that to create chill water for part of the process, and you can use it for heating certain things. It's just going in different places. It's just so it's not just going straight to atmosphere.
Sure. So increased beneficial use coming out of that. Very good. Now, we've kind of talked about like the number of years that some of these plants are traditionally run, or the maximum number of hours that they can be run. What happens if we exceed those hours?
Well, the only plant that has a max hours would be Walnut, the original plant. And the reason that will make more sense is when we talk about emissions. And the emissions on that plant are much higher compared to the other plants, because the longer we've got technology and learned, we've done better. Those older plants that Walnut Power Plant in particular is stopped at 400 hours. That's 200 hours per engine, because if we go over that, our permit says that we'll have done too much PM10, which is particulate matter, causing us to go over our emissions permit. So that's why it's capped at the 200 hours per engine. And when we talk about emissions, you'll see just how high that is and how different it's become.
Okay. And kind of like using your reference of your typical car, as cars have progressed through the decades, they've become more efficient. And I would imagine a similar situation with the difference between our earlier power plants and those that are more modern.
Right. And similar to the car technology in that point is that the catalytic converters and the emission control processes, they've become better over the years. Walnut has very little in the way of catalytic converters and emission controls, whereas both Almond and WEC have ammonia, for instance, and that's
purely for emission control. Okay. And like you said, we're going to dive further into emissions in a minute here. But first, let's get back on kind of the history of our plant. So you just spoken about Almond, our initial Almond power plant. And then in 2012, we built Almond 2. Can you talk to a little bit about the similarities or the differences there?
Right. When Almond 2 was built, it's really, you could consider it an expansion of Almond 1. So you could say that Almond's really just one big power plant, but it's separated for permit reasons. But Almond 2 is basically 3 engines were added. They're all simple cycle and quick start engines. At the time that we did that, we bought 4 of the first of those engines. So we have serial numbers 1, 2, 3, and 6.
Oh, wow.
Even though there's only 3 engines, we also have a spare, which is currently out for repair, but we have a spare that sits there in case we have an issue with one of the 3 that are in place. Unfortunately for us, because we went early, they haven't built many more of those engines.
Oh.
So the fleet is only about 15 engines large, which makes it difficult at times for learning from other people's mistakes or from, understanding what kind of things happen when there's more hours on them, which we do get that kind of use out of our other engines because those are large fleets. And so we see a lot of the things that go on. So it makes it a little bit more difficult with our newer Almond engines.
So really a very smart move to have that extra engine in play because there just aren't that many of them out there.
Right. Which unfortunately is not helping us this year because with supply chain issues,
sure.
For instance, our current spare is at the depot right now. It should have been back by now, but it's just a slow process with supply chain issues.
All right. So going to kind of back up a little bit in the timeline here. In the early 2000s, specifically around 2005, 2006, TID became its own balancing authority. And because of that, needed to expand its generation capacity. And how did we go about providing for that?
So we built WEC, and really that plant was a pre-designed plant from Calpine, who has a large fleet of plants. So we kind of took their design. They decided they weren't going to use all the equipment they had already bought from GE, and so we got a great deal on it and let them help us build WEC. And so it's kind of under their design. You could go to Calpine plants and go, wow, this looks exactly like WEC because it's all similar. They've done their plants all the same way. So, and really just the need for that large amount of megawatts to help us be a balancing authority.
And what is the generation capacity on, and we say WEC, we lovingly refer to it as WEC, but that actually stands for the Walnut Energy Center, right?
Right, which is another point of concern because there's so many things that have to do with power plant business that are called WEC.
Oh, is that right?
Well, one of our, the Western Energy Council, et cetera, WECC,
oh, true. That's
et cetera.
right.
So often are you talking about this or are you talking about your plant?
WEC with 1 C or WEC with 2 Cs? So I'm sorry, taking it back to what is the generation capacity at WEC?
We roughly say 250. It can get to 258 and higher, but 250 is the standard.
Okay. And then now that we understand a little bit more about the combined cycle versus simple cycle, WEC is made up of what?
So there's 2 CTs or gas turbines, combustion turbines. Those do about 75 megawatts apiece. And then there's 1 steam turbine that runs off the back of those that does another 100 megawatts. So when I talked earlier about the whole plant, the half plant, et cetera, one of the 2 combustion turbines always has to be running for the plant to run. The steam turbine will also always run regardless if there's 1 or 2 combustion turbines running. And because of the exhaust situations, we would joke that newer power control operators, hey, why can't you just run 3? Well, where's the steam going to come from? It doesn't work that way. So we need at least 1 combustion turbine to run that steam turbine.
Very good. Okay. Now there's also attached to WEC, there's something that we take into consideration called a heat rating. What can you tell us about that?
All power plants kind of look at a heat rate, and really you're just talking about the required amount of power or the required amount of heat to produce what kind of power, and you get a percentage or, it's a number that gets put out there. You could say that WEC is the most efficient because of that steam turbine, and it sits around 8,500, 7,500 at its best, and that has to do with where in the cycle it is. So if it's at min load, it's not going to have as good a heat rate. If it's at high load, it's going to have a better heat rate. And so for comparison, you could say Almond 1 is close in the 8,500 range as well, but it also is only giving you 50 megawatts. So you still want to go with WEC. Whereas when you look at our other plants, like our simple cycles, Almond 2 at a low load is as high as 12.5. So that's not very good. The lower the number, the better the heat rate. So up at 12.5, that's not very good. And even worse, you could say Walnut up there at from 12 as high as 18,000.
Oh, wow.
So
okay.
It's just not as efficient at all. It's not doing much. So, you're when you talk about heat rate, how much bang for the buck? So you're getting a better amount. It's kind of like miles per gallon. You're getting a better amount out of your gas than you are when you're at a bad heat rate. So WEC's the best, and also because it has the most megawatts.
So another kind of limitation or guideline that we follow with each of our power plants is a certain amount of run hours. And I believe that's measured annually. Can you tell us what what run hours are, and then how many run hours we have on each of our plants?
So anytime the plant's operational, it's counting as a run hour. WEC in particular runs almost year round. You would say we average 5,000 to 7,000 hours a year. I think there's only 8,500 and something in a year. So as you can see, if I take off that extra 1,500, that just accounts for the 2 outages. So it's almost a year-round event. It varies if things happen, but it's mostly year-round. And that includes what we mentioned earlier, 10 to 20 starts total. When you look at Almond, they're more of a 1,500 to 3,000 run hours per year. And that includes multiple starts. So you'll see each of those engines, especially 2, 3, and 4, the Almond 2 plant, start as many as sometimes 300 times a year. And because it's multiple starts a day, every single day, depending on the situation, et cetera.
All right. So natural gas, as we know, is not considered a renewable resource. And because of that, our gas-fired power plants across the nation have come under fire for that. So let's dive into that emissions consideration a little bit more with regard to WEC and any of our other plants. What can you tell us about that?
Well, the main constituents we are required by permit and to look at in California is NOx, CO, VOCs, and PM10, and then also sulfur oxides. But the main ones really we often monitor. We monitor everything constantly, but the main 2 we often talk about is NOx and CO. Those also come from in your car, et cetera. It's a carbon emission. So our NOx, we have gotten to the point now with the newer plants that we're down in the 2.0 and 3.0 parts per million that we're putting out. Whereas, like I said earlier, with Walnut, it's allowed to go all the way up to 25.
Oh, wow.
Which is part of why they don't really want it to run very often. You could also look at that and say, okay, well, when it comes to CO, WEC and Almond are down to, WEC in particular, being the cleanest, is down to 4.0. Almond is at about 11. And then Walnut is allowed to go as high as 200.
Oh, goodness. Okay. So there's a good discrepancy there.
Right. That technology has gotten way better. We do much better. And earlier, too, when I was talking about the 200 and 400 hours. So each Walnut engine can run 200 hours, 400 total combined. We look at that because the PM10, which is particulate matter, another thing we have to monitor, we've calculated that Walnut will reach its limit if you run more than the 200 or combined 400. And so by permit, we know that once that happens, we're going to start getting fined and or just make the decision not to run. Because you never want to just decide to get fined and say, okay, well, I know that I'm violating, and that just means a fine. Because if you continue down that path, your fines are going to either get higher, or the inspection agency is going to look at you and say, well, you're doing this willfully, so now we're going to fine you even more and or shut you down. So you never want to willfully in any way go above those numbers.
Sure.
So we keep a close eye on that.
And just in general, we want to be good stewards, right?
Well,
so we're always yeah.
It's I don't want it to sound like I was saying we could try that. It's we have so many regulations and so many things throughout the plant process. We are always trying to keep the best relationship and do the best we can for the environment. I feel that like these plants, especially WEC and even almond, are very, very clean. And it's apparent from what I just told you about walnut that we do better and better all the time. And these plants, I believe, will be here a while.
Very good. All right. Are there any other unique characteristics about WEC specifically that our listeners might find interesting?
WEC in particular gets all of its water from the city of Turlock through recycled water. That is a requirement of California at this point. You could say something similar about almond, but the big difference between the two is that even though WEC takes that recycled water, it's considered a zero liquid discharge. So we have no sewer pipes at WEC. Everything is, there's a pond for rainwater, and everything else is treated and run through our tower system. And so then the water treatment system then cleans up that water and does a few things. It takes the solids out when it gets too high and turns it into salt cake and then sends it to the city of Turlock for disposal in the landfill. And there's a little small amount of waste that also comes off of that has to be trucked out, but no sewer pipes at all.
Interesting.
Where many plants, like for instance, when I worked at Stanford, we would blow down, as we call it, which is really just send it to sewer, as much as 1 million gallons a day.
Wow.
Of hetchy water, which is very clean water. But that was the standard back then. And that's why you'll see some power plants often built along coastlines, because they're pulling ocean water for their cooling and then dumping it right back into the ocean. And that's part of the environmental issue is that water is hot, and so it can affect the fish, et cetera. But our plant in particular does not do that. And all that water goes to our liquid discharge plant, cleans it up. We have no waste in that regard.
Wow, that's very cool. And probably something that not a lot of people realized. So,
right. It's a very expensive process that takes a lot of management to handle it. And when we talk about how many personnel I use, one thing that goes along with that is that I have contractors required to be on site 24/7 to help us run that process because they were the experts. And at the time that we built WEC, we were not the experts. I'd say we're much closer to that now. It's been the time that it's been built, but at the time we definitely weren't the experts.
Sure. Well, I'm glad that you mentioned personnel, because I'd like to get into that a little bit more. So you have 4 facilities and a lot of generation capacity. How many employees does it take to keep all of this running?
We're close to 40 in the department. I have approximately 15 operators at each of the 2 main plants. So the operators at WEC handle walnut as well. Almond 1 and 2, like I said, it's really kind of more of a combined plant, considered one plant. So I have another 15 operators there, give or take. On top of that, at any time, I may have 3 to 4 apprentices helping to keep that 15. I think right now I have more than that because we've had some turnover. In addition to that, I've got 5 instrument and control technicians, 3 at WEC and 2 at Almond. The 3 at WEC is because, with the zero liquid discharge, there's a little bit more equipment, et cetera. On top of that, we've got a regulatory compliance officer. And because of the amount of emissions and regulations that I have to take care of, he's a big help in that and handles most of it. We have our own admin assistant because we have a very high level of purchasing because of the amount of equipment we have. We do a little bit more than some departments. I think we're probably on the upper end of the amount of stuff we order and the budget we use for equipment. And so she's highly involved in that. And then we also have our own warehouse person because we have 2 separate warehouses, one at each plant, that's not really attached to the rest of TID. Most of TID, when they need something, they go to the main warehouse. Hey, I need some gloves. I need, et cetera. We handle all of our stuff in-house. We order everything and stock everything and handle everything ourselves.
Very good. Now, you mentioned your apprentice technicians. What does that apprenticeship look like?
Like many of the other apprenticeships in the district, is 42 months long. We run them through a series of training. They're doing oral boards. They're doing written tests. They're doing drawings. They have to commit from memory and really just learning all facets, from being a mechanic to being an operator, which is different, to being an electrician, to being a security guard in some respects. There's just many, many things they have to learn in that 42 months.
Wow, very cool. All right. So let's talk a little bit about some of the skills that these roles required. You mentioned just in the apprenticeship training that they kind of cover a number of bases. What are some of the specific skills that you would be looking for in a new employee?
I'm definitely looking for someone who has mechanical skills. Many of my guys, I can rebuild an engine. I can, work on my house. We start with that stuff, knowing that we need those good hands mechanical skills, but at the same time, we also need a balance of operator/computer skills and technical skills. Everything we do in the plant, somehow you're touching a computer. Even if it's a simple oil change, you're going to go log that in the computer, tell me exactly what you did, why you did it, what parts did you use, etc. Everything's computer based for us. And many years ago, even operating the plant was more switches and buttons. It's still like that, but it's all computer based. So you have to know how to read ladder logic. You have to know how to, understand why alarms are coming and use troubleshooting, etc. So it's a highly technical position.
So again, kind of going back to that car analogy that we've been referencing, cars of 20, 30 years ago were much more mechanically based, whereas now if you were to try and fix something that has gone wrong, there's so much more electronics tied up in them. You have to have a different skill set.
Correct. And to even go a step further from that, you could say that in the old cars, you'd see your oil light come on and you'd say, oh, that's got to mean that I got low oil. Nowadays, in your computer driven car, you may see that, but it might give you something else. And then you have to go to a mechanic and say, well, can you plug in the computer for me? If you're operating the power plant, you're going to see those same kind of alarms. But the difference is you have to go read the ladder logic in the minute and try and save the plant, and then have your instrument control tech get involved and help you and be able to understand where to go and how to even find that stuff in the moment.
Absolutely. Yeah. A whole different depth. So I understand that you're kind of running up against an unusual staffing challenge related to those that were hired on back in, what did we say, 2005 when WEC was built? What's going on there?
Well, when WEC was built, we needed a large influx of people because of the 15. We had went from just being just Almond with, I think, a crew of maybe 10. And so we added a couple positions there, added all of WEC, and got lucky that a local power plant was closing down and got a lot of people from there. But the issue is that many of us, including myself, are all around the same age. And so I may have as much as a 50% turnover in the next 5 years.
Wow.
Combined with ages and people's plans, it could all really hit us all at the same time.
Absolutely. And as we've talked about kind of the skills that are needed for someone to come into a role like this, that's not something you find every day. So that could be a definite challenge for you in looking to restaff some positions.
For sure. And the reasoning, the part of the added depth to that is that we've never found journeymen. We've had no success of journeymen over the 15 years that I've been here. It's very rare that we find a journeyman because of location in Turlock, but also just, we're not a dime a dozen. There's not a local power plant down the road
Sure.
that we can steal from, et cetera. So because of that, we need the 42 months. And so in these next 5 years, if I don't hire until the day that somebody leaves, well, I'm not replacing him for 42 months.
Right.
So we're trying to get better at hiring earlier and hoping to overstaff, knowing that it's a short-term situation. That
Sure.
if I have an influx of loss in the next 5 years, well, we've already handled it, and not waiting 42 months, because obviously we can't run the plant poorly for 42 months while we try to train people.
Right. Absolutely. So let's make this kind of an unofficial call out to anyone who might be interested in getting into this line of work, that now is a good time to explore those options.
For sure.
All right. So let's talk about now, you've kind of mentioned this a little bit, but the staffing needs at each plant, because it's different from plant to plant.
Yeah, the main difference is the zero liquid discharge, where we have the extra contractors. Other than that, one less instrument control tech at Almond, but always 2 people on shift at all times, 24/7, 365. No that cannot be deviated, and not just because personally I believe that, but also because of our permits, everything involved with permitting and regulation, et cetera. That's also included in there. There will be 2 people on site at all times. So if I have somebody call in sick, or I have somebody that, just simply can't make it that day, something happens, worst case scenario, myself or my supervisors will be there. There has to be 2 people on site at all times.
All right. And then the staffing looks a little bit different in the day versus in the evening. Obviously, in the evening, you have to have that minimum of 2 people there. And during the day, then who else is on board?
During the day, there's at least 2 to 4 mechanics. The instrument control techs normally work Monday through Friday days, or some amount of Monday through Friday days, whether it be 10s, 12s, 8s, et cetera. And then the rest of the support staff we talked about earlier, myself, the supervisors, the admin, the regulatory compliance officer, all of us are more of a Monday through Friday situation. So all that support staff is there during the day, whereas at night we just leave it to the standard 2 operators. And most of the support staff also, that's not assigned to a plant, works half and half. So like myself, my admin, the warehouse, we do 2 days at Almond, 3 days at WEC every week.
Okay.
And just double our offices, et cetera.
Okay, got it. And that's on kind of a typical day-to-day schedule. But when you guys have outages, and we'll talk a little bit more about that in a minute, that's more of everybody's
all hands on deck.
All hands on deck. That's it. Yeah.
So everybody's there, and that's also 12-hour shifts every day. And so there's the standard twice a year that it's 2 weeks or so, maybe a little longer if you're doing engines separately. But every few years, it can be as long as 6 or 8 weeks.
Wow.
And it still stays 12 hours a day, every single day, all the way through.
Okay. All right. Okay. So let's go back to the different TID gas-fired plants. You gave us a description of each plant, but I'd like to talk a little bit more about the role that each plays for the district. Based on their unique qualities, when are we most likely to use which plant, and under what kind of circumstance?
Well, if we start with Almond 2, which is a quick start capability, they can be started within 10 minutes, give or take. Those plants are easy to just, hey, another plant came offline, get a plant up. That plant's going to get started. Solar's dipping, that plant's going to get started. Any type of emergencies, it's easy for those to come up in a quick fashion. So we'll use those, at different times, more in the morning in the winter where that's your heavy load because everybody's getting up, getting ready for work. Maybe in the summer, it's more in the afternoon. Everybody's going home, turning on their air conditioner. So those run for hours a day instead of all day. Okay. If you compare that to WEC and Almond 1, because of the time it takes to start those plants, we will often leave those running. WEC in particular is we like to leave running as much as possible. So it's often always running.
And what does that startup process look like for WEC? Because it's a much longer startup.
For WEC, you're looking at a 5-hour startup time. And the purpose of that is that, in Almond, you hit the start button, you let the engine come up to speed in that 10 minutes and start making megawatts, and then it can easily go to its full capacity. And so there's nothing else to worry about. When you're starting WEC, you start one of the 2 engines, you let it sit at, say, 10 megawatts or so, sometimes for an hour or 2 hours. And the purpose of that is it's just slowly heating up all the equipment. You got lots of metal to heat up in the boiler. And then once the metal's heated up, lots of water to heat up to get ready to be able to actually make steam. And so you're making that process go along and slowly bringing that turbine up higher and higher in megawatts until you have enough megawatts to make steam. And then you may start to get the steamer rolling. The steam turbine is a very large piece of metal and takes a long time to heat up. So that's another part of that 5 hours where you're just spinning and spinning and you're never getting to the point of megawatts for quite some time. It takes a while for that process to happen. And then eventually you'll bring on the other turbine, even sometimes after the 5 hours. The 5 hours, you just might start one and then the steamer, and then you're allowed to go to power control, and then you'll start the second combustion turbine.
Okay. And that's just by nature of how the plant is built, the multiple different components that all have to work together to make things run efficiently and safely. Is that right?
Right, because as much as I'm saying, well, you just start the turbine and then eventually make steam, et cetera, there's so much more to that. Because
Sure.
when you start that combustion turbine and you get those steam, you have to get it to the right levels. When you go to start the second combustion turbine, you have to blend that steam with the other steam that's already been created and get it to the steam turbine and make sure that that's all done correctly so that you don't have a problem and then end up starting over.
Right. Okay. And then there are also efficiencies to be aware of on the minimum output side of things. Is that right? We spent a lot of time talking about like ramping up to max generation, but are there efficiencies that we have to watch out for on kind of the bottom end of that spectrum?
Right. For instance, at WEC, we will never run a CT below 45 megawatts. And that all centers around our emissions. You can't get emission compliance if you go below 45. So you're at 45 megawatts to make sure you stay in emissions. So if you're in a full plant mode, that means you're at a minimum of 90 plus whatever 90 creates on the steam turbine. So you may be at a minimum, I think it's around 165. So you're not going to get below that because you just can't because of emissions. And that changes depending on what configuration you're in, et cetera. Same thing with almond, walnut. There's a more of a 10 to 12, 15 megawatt minimum, et cetera. But because they only have 50 total, but you definitely are not going to just go, well, I can go to anywhere from 1 to 50. That's not going to happen. You have particulars you have to meet.
All right. So then under what sort of circumstance or for what purpose would we run the almond and the walnut power plants?
So almond 1 is often it can be a support role. So usually when WEC's in an outage for maintenance, almond's running, almond 1 is running. But it also runs to help with our peak loads in the summer. You'll see it run a lot more during the summer, obviously. It's the winter where it's more of a fill-in for WEC and depending on the situation, if there's particular loads or if EIM dispatches it. When it comes to walnut, that's more of an emergency only plant because of that limited number of hours, the amount of emissions. And so I believe we sell some of that spinning reserve, or non-spinning reserve, I should say. So even though it's sitting there, it's available for capacity, even though it may not run. So we use that one in different ways. And I'd say it's really more of a clutch situation, emergency plant.
Okay, very good. All right, so we've touched on it a little bit, but maintenance for these plants is obviously a key issue in keeping them healthy, keeping them efficient, keeping the power that we provide reliable. Let's talk a little bit more about that maintenance. Is that typically conducted by TID staff?
There's a large portion conducted by TID staff, and then there's particular things that we farm out to contractors. The things that my staff do can be anywhere from they're acting as electricians, they're rebuilding pumps and motors, they're rebuilding valves, they're doing logic and controller programming, boroscopes, alignments. And some of these things may sound like, well, that's not that big. You swap a pump, you swap a valve. You have to remember that we're talking about 30,000 gallon per minute pumps. We're talking about large industrial equipment that takes a particular skill set. And on top of that, when we lose or have an issue with any of these pieces of equipment, I don't get to just say, okay, we'll shut down the plant. We'll call somebody out. It'll be a couple of days. My personnel are expected to go figure it out, keep the plant from stopping in the first place and keep it running and get it fixed so that we can continue to run. We don't have any luxury of time. You have to get the plant going now. We save that luxury of time for outages. There's things we simply cannot fix. We'll fix it during an outage as long as we can keep the plant running. But any other time something breaks, they're on the clock, and it's expected to be done as fast as possible, for reliability reasons.
Sure, absolutely. So then what type of work would we need to call in a contractor for? It sounds like staff can take care of 90% of the issues.
The main thing we would use contractors for is if it's more cost effective. Even though my personnel could do it, it may be more cost effective with a contractor. But the other main thing is that the turbine work. So the large gas turbines at WEC, they get rebuilt on a regular basis with parts sent out, et cetera, things that they do. And that's a very specialized craft. And so we contract with GE and they come and work on our turbines. We do something similar in Almond where they do a lot of turbine work, but it could be other things that it just wouldn't make sense for us money-wise, even though we may know how to do it. An example would be we had a fire valve. There's a water system that runs fire water through the plant. It's underground. So if you think about when you see city workers digging up something for the sewer or whatever in the middle of the street, where you cut out pavement, go down inside, then fix the valve, and then repave it, I'm not going to ask my guys to do that. They could do it if they had to, but we contract that out because it's just not, we don't have the equipment on hand. You know, similar to things at your own house. You know, there's many things you could do, but you might go, well, now I got to go buy a tile saw and I have to buy this and I have to buy that. So it makes more sense to contract it. Those are the kinds of things we look at.
Makes sense. Okay. And now, just from our conversation, it sounds like you sort of alternate smaller maintenance jobs with larger maintenance jobs. Is that intentional? Do you try to kind of schedule that out?
We have a pretty rigorous maintenance schedule for all equipment where we're either looking at how many hours something ran, how many times it started, different factors. We work on things during the outages because we can't stop the plant to work on them any other time. So we push them to that. We also have large maintenance items. Like I mentioned, the craft from GE on the large turbines at WEC. The example I would give is on your own car, you change your oil every 3,000 miles or every 5,000, whatever it is nowadays. We do the same kind of things, but then imagine if on your car, not only do you need to change your spark plugs every so many thousand miles, but you also need to take the pistons and the rods out, send them out for inspection, put a separate pair in while you're waiting for that inspection. That's the kind of things we do with the turbine, where we send out parts. They often go all the way to Indonesia, Malaysia, etc. They get inspected, they get repaired, they come back. At the same time with those parts, we have a certain number of hours we can run. So, for instance, those parts have been replaced more than once since WEC was built, and they're getting ready to be replaced again because you can only run them up to so many hours, and then GE will say, well, we just can't fix them anymore. Even if they can, we don't trust them anymore because the metal fatigue. So those parts then have to be replaced. So there's a constant rotation. We have 3 sets of parts for those 2 engines so that one can be off at repair while the other new set gets put in, et cetera, et cetera. It's a large process. I
was going to say, yeah, with a lot of different redundancies, because again, it's not like you can run down to the local hardware store and get what you guys need. There's a long lead time in getting some of these things replaced.
Right. And the logistics of all this is one of the many things that makes my supervisors and my support staff different, because they're managing all that and they can't just recover from a mistake. If they make a big mistake, the plant's going down or not going to be able to be repaired at the proper time. So there's a large responsibility on those supervisors.
Absolutely. All right. So we hope that the outage of a plant only takes place during a planned outage for maintenance.
Right.
What can you tell us about how often these are scheduled? And I would guess that plays into maintenance, testing, different inspections. How do you go about scheduling those planned outages?
Standard outage planning for any power plant that as far as I'm aware of, is there's always a spring and a fall. Okay. So we shoot for sometime in the spring, sometime in the fall. We would like them to be spaced out 6 months apart. You know, the analogy I often give is the oil change. I wouldn't want to do it 3,000 this time, 1,000 next time, 5,000 next time. I want it to be standard. So we shoot for the 6 months. That's not always possible because of, other issues throughout the district, from pole painting to Don Pedro outages that can only be done at certain times, et cetera. So we do our best with that. We do also do that because you don't want the plant to have been running 8 months in the middle of summer because you did your spring outage too early. So there's some factors that go into play there to make sure those things are happening at the right times.
Sure, that makes sense. And even just what we had spoken about earlier, that we're seeing kind of our peaks later in the summer. I would imagine that gradually then has to shift your maintenance schedule because, like you said, you wouldn't want to do your spring maintenance too early, knowing that you're going to run into end of September, October with some of these peak loads.
Right. I would say 10, 12 years ago, I can remember some of my first outages here where we would do an outage in as early as September. There's no way that would happen now. It would not be allowed because it's just too hot in September. It's not unless we have another shift in temperature or cycles, which could happen. We've seen this before. It's just not going to happen next time. So we always are pushing towards the end of October, preferably November, just because of the weather cycles.
Sure, that makes sense. So now when you're looking at scheduling one of these outages, I imagine that doesn't happen in a vacuum. You can't just take WEC offline for a planned outage for whatever the maintenance issue might be. I would assume there has to be a lot of coordination throughout the district when planning for these. Can you tell us a little bit about that?
Yeah, every department is involved to some extent. We have 15-month outage meetings where we're planning out 15 months in advance at a minimum. We're looking at what other people are doing. Is there transformers down in an area? Is there pole painting going on? Is Don Pedro available to run? Are my own plants available to run staggered at different times, different issues? And so we have to take all that into account to get to where we need and make those decisions.
So one of the groups within TID that I know you guys have to coordinate with on these outages that I think is probably one that people wouldn't necessarily think of right away is our resource planning group. And the resource planning group kind of schedules out more long-term contracts. So how does that coincide with planned outages happening in the here and now?
They're also looking at capacity. So they're saying, okay, do we have this? If our plants go down, do we have the availability to get that capacity from somebody else? And they have to plan for that at all times. So a standard that they use at this point is that if you are down for more than 7 days in a month, they plan as if you're going to be down for the entire month.
Oh.
If you're only down for 1 to 7 days, they'll plan for that 1 to 7 days and say, okay, let's buy extra capacity for that. But if you just go 8 days, well, now they're going to buy extra capacity for 30 days. And so it's much more expensive. You have to make changes and look at that. For instance, the last 2 years, we looked at May as our spring outage at WEC. We originally wanted, I believe, 10 or 12 days. We talked to resource planning. We scaled it back to 7 days, pushed a little bit more into April because we were already going to be over 7 days in April. So why not push 2 or 3 extra days in April versus 2 or 3 extra days in May? Because the shift in money, the shift in capacity, et cetera, all has to be looked at.
Okay, so let's get into a little bit of reporting, because I know you'd mentioned when we were talking about emissions that there's a lot to keep track of. There's a lot to make sure we're hitting certain thresholds. We're not going above certain thresholds. I imagine all of this has to get reported out somewhere. So let's talk a little bit about how all that comes together.
The reporting for emissions is one particular area. The emissions at the plants are monitored 24/7 all the time. There's an analyzer. We're measuring what's going through the stack, no different than out your tailpipe on your car. But the difference is we have that smog check in place 24/7, and it has to be online and it has to be working properly. It gets calibrated constantly. We can't even change our analyzer without reporting it. We have to tell them what we did. And so there's a lot that goes into that. And if there's any sort of alarm, breakdown, et cetera, we have to report it. We have to report it within an hour. So personnel on shift have to either call or fax or email, figure out their way, and we have a process in place. And our regulatory compliance officer has to get involved. But that's a regular thing that happens constantly.
Now, you refer to this they, like if we have to replace the analyzer, we have to let them know. Who is the they?
So the main group at the moment is the San Joaquin Valley Air Pollution Control District. I'd give you the acronym, but obviously that's a long one.
That's a long one.
But so they're always involved. So we're in constant contact with them. Beyond that, we also do monitoring on that emission system once a year where we have to hire a third-party contractor. They come out, they plug in their own smog control type stuff into the stack, check and see if our machine reads what their machine reads, makes a report. All that has to go again to the SJ, VAPCD, the long letters.
Air control board. We'll
yes,
summarize
all that has to go there, and they check that constantly. The only one that doesn't get checked yearly, Walnut's every other year.
Okay.
But we still do it yearly because we just do one engine this year, one engine next year, et cetera. But that's all constant all the time.
All the time. All right. So then what are some of the other maybe less frequent reporting standards that you're required to meet?
So we have everything from a map of where every piece of haz waste is at the plant, at each plant. We have pollution control documents. We have, where is it getting stored? Where is it getting disposed of? The CEC is involved. California Energy Commission, which I've talked about before with the 49.9 megawatts. Mm-hmm. They look at everything from, from the trees at the end of WEC when you come in the entrance are regulated by them. I had to ask permission to remove the dead tree.
Wow.
There's also the EPA that's involved. The waste that leaves from the zero liquid discharge system is all regulated and permitted. The list goes on and on. The other big one that we deal with regularly is ammonia. Because of the volume of ammonia we have at each plant, we have what's called an RMP, which looks at if ammonia was to leak, how would it affect the community? How far does it go out? There's a map that shows what's within that map, what's in that circle. There's training requirements. There's just a litany of things in that book that we also have to get redone every few years. We have to have earthquake inspections because of that book. We have to have equipment inspections, et cetera, all regulated by OSHA. OSHA has inspected that before for us, and then also inspected other things that kind of touch that. We talked earlier, maybe not earlier today, but we talked about the respirator program, for instance. That was spurred from investigating the ammonia, because when you work on ammonia, you have to be respirator qualified. So there's things that all touch each other that just adds to more and more inspections or more and more agencies.
Yeah, absolutely. Now, much of this reporting, it sounds like, is a compliance check to make sure that, we're doing the things that we're supposed to be doing. We're completing the trainings that we're supposed to be completing, and that's all in compliance with these different standards. Are most of these reporting scheduled outside of the emissions, which happens all day, every day? Are most of the rest of these reportings on a set schedule, or could they happen based on an issue, or are they triggered by something else?
Multiple triggers. So emissions all the time, every day. But if there's an issue, report it. Same thing with all of these other items. Some of them we're getting checked once a year, maybe once every 6 months or quarterly. But if there's ever an issue, it must be reported, and you will be regulated on, did you report in the proper time? So all those are kept track of. And there could be anything in there from, as I mentioned, about the respirator situation, our IIPP that just regulates TID itself. There's a line in that book that says the respiratory program will be monitored and ran by the EH&S department within TID. My OSHA inspector decided that, well, you're running it, so therefore you're not following your IIPP because health and safety is not running it. We had no problems. Everything was being done properly, but we weren't following that book line by line.
Wow.
So any little thing can trip you up in that manner.
Okay. That definitely adds another layer of complexity to making sure that you have all the right information in the right place and it's getting to the right people. So I want to kind of take a little look forward. As I mentioned in the intro for today's talk, the state currently has a goal of 100% carbon-free retail load by 2045. And we mentioned that natural gas doesn't fall into this category. So what does that actually mean for the future of TID's natural gas-fired plants?
What I believe it's going to mean is just a different way of running us. And maybe will become more of a peak situation. Maybe you'll see WEC run more in the summer and not in the winter, which we've done at times, but more so coming up. Those kinds of things could happen. I don't necessarily believe all of that's going to happen because there's two problems with it. One is we simply don't have the energy to replace it. As they make these mandates, they're taking this number and saying, we've got to get this many more megawatts. Well, at the same time as they're doing that, population is growing, electrification is growing. Just the fact that all these electric cars are going to increase the need of the grid tremendously. Mm-hmm. If everybody suddenly had an electric car, we don't have enough megawatts. They don't exist. So I don't know if 2045 is a little pie in the sky, but it's definitely we're going to need a whole lot more megawatts if we're going to make any of this happen. And so I highly doubt power plants are going to be gone that fast. It's too much power.
And as we've talked about in previous episodes, yes, we're all in favor of the push towards renewable energy, and that's great. But as we've said, the sun doesn't always shine, the wind doesn't always blow. So you have to have that constant. You have to have that reliable source of energy. And like you said, and unless something else comes along to fill that void, how do we get away from it?
Right. And I think that's the other thing that is not always taken into account. People look at solar and wind and say, well, the prices really came down, but it's still tremendously more expensive than my natural gas power plant. And they also don't look at the entire cost environmentally of some of those things. For instance, solar panels have a life. Where are they all going to go when they get taken off these roofs? They only have a life of 20 to 30 years, I believe. They got to go somewhere. Same thing with batteries and all these battery-powered cars. At some point, they're no longer just reusable. They have to go to a landfill. So I don't have as much from my power plant going to a landfill. I'm not going to say I'm completely clean. But
sure.
That there's issues that aren't always looked at in this realm.
Well, and I think you touched on another important one is just the cost in general. That's something that TID has to be genuinely concerned about is we can't just implement new sources of energy at a tremendous cost to our customers. We have to balance the reliability with providing cost-effective energy. And I think that's a key in this whole picture as well.
Right, I agree that the cost of some of these items is tremendous. And I think that the reason that TID is lucky to have some of the lowest rates, if not the lowest rates in the state, is because we built WEC at the right time and we have the amount of megawatts we have for ourselves. We're not relying on other entities.
Absolutely. Another thing that we've touched on even here today is the differing weather patterns that we're seeing. The summers are getting hotter. When we experience drought, it's lasting longer. We know that these are changes that we're going to continue to deal with. And when we have those extended heat waves, there's even more pressure put on our system for that reliability. And it sounds like our natural gas-fired plants, that's when they really step up.
They do. And if I had my way, we'd build more. and really not just selfishly, but because of the way things work. If you're telling us that the load is going to be into the 700 megawatts, and then eventually if you looked 5 or 10 years out, well, we're probably going to be in the 800, 900, et cetera, or more, and you still want to keep our ability to only generate 500, and even if I throw Don Pedro on and say it's 6 or 7 or whatever that number ends up being, that's not a way to run a business. If your max load is say 1,000 megawatts, preference is probably that you own 1,500 megawatts so that you can always have the possibility of something breaking and you not affecting your customers. We seem to be going backwards. Our load continues to grow and our portfolio of things that are reliable 24/7 is diminishing, and we should probably build more.
And that's in large part because of these mandates that the state is putting upon us. We don't have the breadth of options that we would like to have.
Correct. If these mandates were in place, we used to talk when WEC was first built, that we would expect that another WEC would be built in Patterson in the next 5 years. That disappeared with all these mandates.
So it sounds like despite some of these mandates that are being put forward, we're still kind of looking for the realistic path in which we might phase out our natural gas plants.
Yeah, originally natural gas was supposed to be the bridge to this new, greener future.
Mm-hmm.
But I don't think we've got the other side of the bridge built yet. I think we need an invention or some other way, because we have looked at other things. We looked at hydrogen. That's cost prohibitive. That it would be very expensive. We would lose megawatts in the battle. You know, if I was to put hydrogen at WEC, it may, number one, be very expensive to do, but number two, suddenly WEC's now a 200 megawatt plant instead of 250 because it takes 50 megawatts to create the hydrogen.
Oh, I see.
And it's not even necessarily cleaner. It's because of the way it burns, and it's not as simple as saying that hydrogen is just, water, et cetera. That's not the whole story. It still has to burn, and it still creates emissions.
And we know, we've had hydrogeneration in our portfolio forever. So we know that that's not a renewable source, but technically a carbon-free source that we can look to. But again, in years of low water, that's not an option for generation.
Right. You're still, yes, it's renewable, even though it's not classified yet, but you still are waiting and hoping that you have a proper water year or that you're storing enough. And we don't seem to have the ability to build more storage, but it's something that you can't necessarily rely on 24/7, 365, regardless of conditions. It's still very condition based. So as I mentioned earlier, when we talk about, Don Pedro can only have their outages during certain times. Well, that's because they're required to flow during certain times. So you can't take them down because you have to let the water flow, and you have to not have an outage when the snow is melting, or you not have to have an outage during this condition. So it's not quite as simple when it comes to hydro.
Sure, absolutely. Yeah. And we've spoken about the intermittency of solar and wind. So it's not for lack of exploring other options as far as TID's portfolio. It just sounds like we haven't really found the right replacement yet for natural gas.
Yeah, I would agree with that. We definitely have looked at lots of avenues. We're exploring batteries. We're looking at different things, but we have yet to have something that's 24/7, 365 reliable as a natural gas plant is.
Absolutely. Well, and I will say this, in our next run of triple-digit weather that we get, which we know is going to happen, I'm going to go home and turn on my air conditioner and be very thankful for WEC. So appreciate you and all that your team does.
Thank you very much. That my team does an excellent job. I can't give them enough credit.
I fully support that and endorse that. Mike, thanks for being here today.
All right. Thanks for having me.
Thank you for tuning in to the TID Water and Power Podcast. You can find TID on Facebook at facebook.com/TurlockID, on Instagram and Twitter at TurlockID, and on LinkedIn as the Turlock Irrigation District. I'm your host, Constance Anderson. We'll see you again next time.